Thanks. Hello. Good morning. Welcome to the Ghosts of Cross-Site Scripting Past, Present, and Future talk. We'll start by having Pete Perfetti start out. He's been involved in IT security in the financial services industry for 10 years. He's worked as an information security officer, done work for Viacom, MTV, the NBA, local information security officer for ABN AMRO. Let's see, leader for the New York, New Jersey Metro chapter of OWASP. He specializes in vulnerability and risk assessment and management, investigations, incident and audit response, prevention, and recovery. Also developing, enhancing, and implementing security and risk management programs. Also does a lot of work with federal government agencies. Following Pete will be Jim Manico. He's an OWASP volunteer and the Vice President of Security Architecture for White Hat Security. So Pete.
Thanks. How's everybody doing so far today? Austin's a great place, and the folks down here do a pretty good job of organizing it, I think. So, welcome and enjoy the conference, and don't forget the OWASP, overarching organization that this is all part of. Jim and I were going to talk to you about the cross-site scripting. Oh, sorry. Yeah, okay. Cross-site scripting, we all know, we talk about it a lot. It's been around for a while. And one of the things that I come across with it in the field is, especially doing vulnerability assessments and penetration testing and things like that, I see it all the time. And it really does cause a lot of problems, whether they're just simple audit and compliance issues or real seriously, opening up avenues for attack. How many here do vulnerability assessments or audits? Okay.
How many are developers?
Yeah, how many are you guys are developers mostly? Okay, so you guys bear the brunt of the auditors and the vulnerability assessment and penetration testers coming in, right? So I see this coming across from two ways. A lot of times people talk about the cross-site scripting and from the development angle on how we can fix this. We all know we see those issues out there. One of the other interesting parts about it is if thinking about it from my perspective or from the auditor's perspective, or the IT guy. You guys are building great programs, but it's running on somebody else's infrastructure or corporate infrastructure. So when folks come in and we find these vulnerabilities, we find them embedded with other applications. Maybe a company's bought a product and it's got Apache and it's got some other things built into this. They're all part of it. We can't fix those. So what happens is now the IT guys are they're stuck. They're not developers, so they can't fix it.
How about XSS and home routers?
Yeah, cross-site scripting and home routers, right.
Fix that stuff.
Yeah, so I guess here, hopefully we're going to bring up some awareness for everybody, and maybe we can start to get people to fix the little snippets of code that we have out there, so this stuff hopefully will eventually go away. But at the very least, just think about it and see how this is all impacting it down the line, that we can find the vulnerability, but there's nothing we can do about it. And we've got some other ideas and other ways that we can probably help mitigate this risk, if not eliminate it. So, why is it so serious? We all see these vulnerabilities: the session hijacking, the site defacement, network scanning, cross-site request forgeries, the phishing. This is all stuff that goes out there. We all see this. We all know about it, but it's real. And being involved in a lot of the attacks and investigations, I see this happen a lot. Not necessarily through just cross-site scripting, but through other vulnerabilities as well. And together, this all increases the company's risk. And in the end, this is all what it's all about. In one of my other talks, I talk about this. There's a security aspect to it, but in the end, this is all business risk. There's reputational risk involved. There's financial risk directly. There's legal and regulatory issues that come up. And hopefully we can all, I won't say make the world a better place. That's really bad. That's all good and fine to say, but I know when I go into a place or when I've worked for other people, I'm not necessarily doing it to make the world a better place. The bad guys are out there, and as long as they're not bothering me or my clients, I'm happy. You know what? I'll make the building secure, figuratively speaking. I'll make them go to the next place, the guy next door, because he's the guy with all the open doors. he's the guy with the broken windows, the doors and windows are left wide open. That's where the bad guys are going to go. And I think when you think about it, you ever heard the story about the outrunning the bear? Yeah, well, I don't have to outrun the bear. He's the bad guy. I just have to outrun the next guy. So as long as I'm more secure, they're going to go somewhere else. So just some things to think about, and I think maybe now we'll just turn this over to Jim to get some of his stuff going, and have at it.
Thank you, Pete. Thank you, I appreciate that, Pete. Let me get myself dialed in here. Is that good? Please forgive me, I'm very sick and I'm losing my voice a bit. I'm just going to charge anyway, so. Let's start with cross-site scripting and the severity of it. And at OWASP, we consider cross-site scripting to be the number 2 item in the OWASP top 10. It's a relatively big deal. Most times, cross-site scripting vulnerabilities are rated to have a relatively high severity. The problem is that cross-site scripting pops up so much. In almost every assessment I've ever done, I've found a significant number of cross-site scripting vulnerabilities. And most of us who do security testing, they have that same kind of experience. And so because it comes up so much, and it's hard to squash on a permanent basis for a large enterprise, I see more and more managers brush it under the rug. It keeps popping up. What am I supposed to do about it? The other perspective is at White Hat we do a lot of metrics. So when we find a vulnerability in someone's website, we keep scanning and keep checking it on a regular basis until it's fixed, so we can apply metrics over time. We have some folks who had the same cross-site scripting bug for years. So we see often even large high-end organizations who choose not to fix this stuff. And I conject that my conjecture as a developer, my main role in life, I've been building websites for 15 years. I'm not really a security guy per se, I'm a developer. And we'll get more into developer-centric information in just a few moments. But I say cross-site scripting is a big deal. It is a high-level severity issue because it completely undermines your browser. So let's go through these. Session hijacking. So again, what is cross-site scripting? Cross-site scripting is where I, as a bad guy, can inject JavaScript, arbitrary malicious JavaScript, into my victim's browser. That's it. Like we might be cross-posting to comments on a forum, and I post comments that include JavaScript, and someone else reads that comment, is able to execute that JavaScript. That's the basic vulnerability pattern. The other part of cross-site scripting is reflective cross-site scripting. Suppose the attack payload cannot be stored in the website, but suppose I can build a URL that includes the attack payload. It's a real URL to your domain, but when someone clicks on it, one of the parameters includes JavaScript that executes. That's called reflective XSS, two basic categories. So when this attack happens, what can the attacker do? Number one, session hijacking. Window.location to some evil server plus document.cookie. When that executes on your site, it grabs a copy of the current user's cookie and it passes it off to a malicious server for collection. And their server logs will show your cookie, which includes your session data, which allows the attacker to relatively easily hijack your session. Or site defacement. Who here is a developer? Developer, I'm so happy to see so many developers in this room. This is excellent. So developers, what JavaScript can you do to completely deface any website? You tell me. What JavaScript will totally overwrite the HTML of the entire site? Document.body.right or document.body.innerHTML is new code, and that's it. So the attacker needs to get like one line of JavaScript into your system and get a victim to click on it, and they can overwrite the entire DOM. Now, you can even overwrite targeted parts of a page. How do I overwrite one particular element in the DOM? Document.getElementById, the element's identifier, and then innerHTML or setElement or different APIs based on what that component is. So now we can, in a targeted way as an attacker, say, what if I say just overwrite the source attribute of your login form? What happens? Yeah, you log in, and that login information goes somewhere else, and somewhere else now has your password. This is a big deal. Network scanning. This is not just cross-site scripting, it's any JavaScript. You surf to an evil website, malicious JavaScript gets executed in your browser. So I'm sitting in my deck in Hawaii. If I was an attacker, if I can trick you into going to a malicious page with malicious JavaScript, that JavaScript loads in your browser, in your private intranet, behind, millions of dollars worth of firewalls and IPS devices, and then that JavaScript lands in your browser and starts port scanning your network slowly, collects that data and ships it back to me as a JSON object, boom. I now can remotely do port scanning inside of your network through JavaScript cross-site scripting, undermining cross-site request forgery defenses. First of all, how do we stop cross-site request forgery? Give me the simple one. Whoa, who said that? Some sort of random cryptographic token in a form to make your endpoints random. That's the main defense for cross-site request forgery. When you're using those random tokens, though, and you're hit by cross-site scripting, a chunk of JavaScript, it's a little complex, but not so bad. That attack can go make a request to your server through AJAX, grab a form, use a get element ID type of API to grab the token out of that form, build a new request, and make that new request and steal your token and undermine your cross-site request forgery defense. We saw this in the anti-SAMI attack against MySpace. We saw this in the Twitter worm about goats. Remember the Twitter worm not too long ago? It's a Twitter worm that would execute, all you had to do is look at a message and it would post that you love goats. And anyone else looking at your message would also post that they love goats. No offense to the goats now. If you love goats, that's your business. Yeah. I don't want to take your goat love away from you, but I personally did not want to post that myself, so. That hurts. That really hurt. Suppose you hit with cross-site scripting and we want to redirect you to another site that's a phishing site. So what JavaScript will redirect you to a different site? Document.location, exactly. These not difficult attacks is the point I'm trying to make. We can also load a script from an entirely different domain and run it. We can do full-on data theft of any piece of the DOM. Set up a keystroke logger. Oh great, now with HTML5 we have web workers, so I can set up a keylogger to run in the background of your browser, always running and logging on multiple domains. It's getting out of control. When I do a proof of concept against the site, yeah, Mr. Feff.
I was going to say, things really pivoting port scanner.
One more time?
JavaScript, could you write a port scanner?
Yeah, you came in late. It's okay. I'll get a note from your mom later, please. No, but you're right on. Bullet 3, you can do a full-on network port scan with JavaScript. There are full-on port scan attack kits out there already. And for the attacker, it's just one chunk of JavaScript that loads a remote script. Game over. Then you can take that scanner, run it as a web worker, turn in the background. So even as you do different page changes, it will still run in some situations. Like you pop a 1-pixel iframe or you pop a 1-pixel window with the web worker behind it. As long as that's not caught, now you have regardless of what you're doing in the browser of different domains, that web worker HTML5 is running in the background port scanning while you're surfing different pages. HTML5 makes this 10 times worse. So, right on. So my favorite is using the Stallone image to deface a site. So when I go and demonstrate a vulnerability, very often I'm asked to, very often I'm told, I don't believe you, you're full of it. I'm like, okay, so prove it to us. So I want you to prove a live exploit on my site that you can really cross-site scripting attack us. Like, okay, so I remotely load jQuery and a couple images, and I sound some music, I show 2 curtains, the curtains open up, and Sylvester Stallone, and it's dramatic, it looks big, and it's live on your homepage. When I do this in Stallone, I think it's like the height of good humor. Recently, I showed this to a CIO of a major Fortune 20 on his homepage. He did not find it as funny as I did, I found out. So, no sense of humor. Oh, wow. So let's get into it now. So if we go back to the 1990s, the 1990s is when, the early 90s is when cross-site scripting first came about. What did we as a security community, and JavaScript was not used as much back in the 90s. In fact, if you're a web developer in the 90s using a lot of JavaScript, you got dinked for doing that. You were thought of as being a bad developer to put a lot of JavaScript in your page back in the early 90s because JavaScript did not work in a cross-browser way well. It was really slow. It was buggy as all heck. It was not something we used a lot in web development early 90s now, the dawn of the web age. In fact, one of my requirements was in many of my websites for GE, I was a GE programmer for many years, and it was you are not allowed to use any JavaScript. It was actually a core requirement. Doesn't exist anymore today. You can't build a real website without JavaScript, pardon me, today. So back in the 90s, we would tell developers, just strip out these bad characters. Just strip out less than, greater than, ampersand, semicolon, dot, single tick. Let me ask you, if your strategy today is to strip out these characters, and that's your main strategy for cross-site scripting, what do you think of that? Why does this strategy not work? You're right, but way simpler than that. What if you tell... I agree. Give me more though. So you tell your boss, I need to strip out... Let me give you a specific example. So you have a last name field. First name, last name, address 1, city, state. You have a last name field. What if you're stripping out the single quote in your last name field? What country did you just piss off? You don't mess with the Irish. I know you guys are good fighters in Texas, but Irish know how to fight, man. You don't mess with the Irish. But seriously, you break business requirements when you start stripping out characters. This strategy doesn't work then. It doesn't work today. It's not going to work tomorrow. But this is the advice we gave in the 90s. And any data, just do some kind of input validation. This is absolute fail. We need to do better than that. So now we're jumping ahead to about year 2000. Year 2000 is when we first started talking about HTML entity encoding. This is the dawn of the AJAX era, the beginning of heavy JavaScript-rich internet application development, just the beginning of it. So now it was a little bit more okay to use heavy JavaScript in your site around year 2000. And this is when OWASP first published its article on HTML entity output encoding. So we would say, we'll just take, for every character, just take that character and replace it with this HTML entity equivalence. So for a less than sign, we would replace that with ampersand LT semicolon. When the browser sees a less than sign, it's going to try to consider that to be part of a tag. And it will start to open up the HTML rendering engine and start to parse that like HTML. When the browser sees an ampersand LT semicolon, what does it do? I'm sorry? It displays the character, but what doesn't it treat it like? You're all right. It doesn't execute. It doesn't treat it like a special character. It just renders it on screen. So HTML entity encoding, in some cases, it is the right answer. But you tell me, now think of how complex our web development is. If I go to a developer and I say, just do HTML entity encoding everywhere, and cross-site scripting is going to be not a problem anymore. It's all fixed. What's wrong with that strategy? I'm sorry? That's fair. I need something more than that. This is not, here's what I'm trying to say. This is incomplete bad advice. Why? Can you raise your right hand for a second? Push forward. You raise one of your hands. Push forward. High five. You said the right word right away. Multiple context. That's all you had to say. You had me at multiple contexts. There you go. So that's the thing. When you take input, untrusted input from a request, and you display it in an HTML page, you need to encode it and validate it different for different contexts. If it's in the body of an HTML document, you do HTML entity encoding. And if you put it in a JavaScript variable assignment, a cascading sheet value assignment, an attribute in a tag, you have to deal with it in a completely different way. And I'll talk about that in a moment. So now we're at year 2000. We're saying any piece of data, just do HTML entity encoding. This strategy will not work because it's incomplete because of multiple contexts. Based on, now we're jumping ahead to about today. Now we're looking at the advice that we've given starting around year 2007. 2007 is when the OWASP XSS cheat sheet was first pushed out. It's one of the first documents to ever talk about multiple contexts for XSS output encoding. It wasn't correct when we first pushed it out, but it was a start. And I'll talk about some of the flaws in our strategy in just a moment. So now we're around year 2007. We're for the first time talking about multiple contexts. And based on where data goes, we deal with it differently. HTML entity encoding, HTML attribute encoding, cascading style sheet hex encoding, JavaScript hex encoding, and URL validation, URL encoding, and attribute type of encoding, depending on where that URL goes. Depending on your data workflow, we have to do different defenses to really stop XSS. We've only talked about that in the last couple of years. So this is, even though this is what we say today, in my mind, this is the past. It's not enough. We're saying first do some kind of canonicalization, reduce data to its simplest form. That's just taking a raw piece of input and decoding it every way we know. We say, let's do HTML entity decoding, UTF-8 decoding, URL decoding. We've now reduced data to its simplest form, then do input validation, and then do output encoding based on the context of display. So what this means is when you're taking data and you're putting it into a database, you can't encode in the database for the most part because that's assuming where it's going to be displayed. So I recommend you do your output encoding in your template at the time, at the parser boundary, when you're about to actually display that data to a user. That's when you know the context. That's when you can apply the right encoding, and that's the right place to deal with XSS for the most part. That's what we say today, and this is what today's advice looks like. We talk about different contexts of where the data will go, and we talk about a different encoding to apply. Back in 2007, 2008 is the release of the JSoup library for Java, HTML sanitizer for PHP, and other HTML validation libraries, because here's an edge case. If you're taking HTML input from a user, anyone ever use the tiny MCE widget in their page? What's tiny MCE? Exactly. Tiny MCE will turn your text area into a rich text editor as one HTML widget. It lets you bold, underline, color, add bullet lists, and all kinds of rich, rich content modifications to a simple text area. When you submit a tiny MCE text area, what does that request parameter submit as? It's not plain text. It's HTML. It's a chunk of HTML. How do we output and code HTML and still render it? We can't. If you apply HTML entity encoding to HTML, it will just render as the code and not actually do the markup. So how do we take a chunk of HTML from a user and render it to another user in a safe way? This is a really common use case in web development. So we need to do some kind of validation. Now, a simple regular expression is not going to cut it here. We need a high-end HTML policy-based validator that lets you configure. I'm going to accept a couple bold tags. I'm going to accept italicized or underline. And there's tools like JSoup, Anti-SAMI. There's a few tools from PHP. They're not perfect. They were decent in this era. They at least reduced the risk of submitting HTML, because most every application I ever saw, they would take the HTML and just render it, and that led to easy cross-site scripting. Mr. Pfefferman.
Was this about the time that Microsoft and cross-site scripting libraries came out?
Yes, they were a little bit later. They were about 2008, 2009. They saw us do Anti-SAMI. They basically copied it for the .NET architecture. So we have a lot of these APIs in .NET to handle this. And again, this is 2007, 2008. Things have changed a bit since then. For example, I'm going to harp on, and first of all, why is this strategy not complete? This is a trick question, a difficult question. But I'm saying that this strategy from 2007, 2008, it's not enough. It's not even close to being enough. Why? Let me answer that. So around this era, we're saying if you have a cascading style sheet value and you're dumping it in a cascading style sheet context, just do cascading style sheet hex encoding and everything is fun. Everything is great. Well, back in 2009, February 12th, we got an email from Beck1 at SE Global who said, I got some bad news. Your advice to do cascading style sheet output encoding was bad. And here's the test case. The test case shows that when you have untrusted data, when you have the temp3 variable at the top there, when you have untrusted data landing in a cascading style sheet context, even if you apply the proper encoding, line 2, we're doing encode for CSS. The developer here is doing what we told them to do. They're applying cascading style sheet hex encoding. Even when you apply the right encoding, this attack will pop in Internet Explorer 8, Internet Explorer 6, Internet Explorer 6 and 7, as well as Internet Explorer 8 in Quarks mode and 9 in Quarks mode. Who here still depends on IE 6 or 7 in their business in some way? I usually get about 50%. That number is decreasing really fast. But still, we need to survive. Yeah, not by choice, believe me. IE6 is the devil, in my opinion. Well, let's not go there. Well, let's go there. We already went there. So, IE6 from a developer point of view, I can't. Whenever I bid on a project to do web development, I say, if you want me to support IE6 with your advanced JavaScript, then I'm going to double the price. And it's not an exaggeration. That's real metric in terms of how much time and effort it takes to support IE6, IE7, IE8, and Firefox, and Chrome, and Safari with rich internet applications and have it still work everywhere. IE6 is a pain. And they pop expressions. This is a CSS expression, alert, string. Now, Microsoft admits that this was foolhardy. They no longer support it in IE 8 and 9 unless you're in Quarks mode. Then they do support it, and they're going to roll away from it. But, so we're good, right? We're good. We're giving good advice. We thought we were. And even the experts, the best experts out there were making serious mistakes in telling developers how to stop cross-site scripting in edge cases like this. Here's another big expert in the world of, again, this is like now kind of getting close to today now. So Adam Barth is probably one of the sharpest Ajax JavaScript thinkers out there. He's a real high-end smart guy. And he recently came out and said, all of you people giving advice about DOM XSS is wrong. DOM-based XSS is when you make a request, you get a response, and then by messing with widgets within the page, you execute cross-site scripting. It's not a round trip back to the server. It's XSS that happens while you're interacting with the browser in an asynchronous way. And we don't have the luxury of all these output encoding functions to apply. We're stuck in JavaScript, so it's a much more difficult issue. JavaScript is also a wide open language. There's so many dangerous functions that can execute JavaScript, like eval and set timeout. It's a much trickier problem when we deal with DOM-based XSS. So Adam Barth, smart guy, I respect him a great deal, came out with this simplified advice. He said the initial page should be a simple static content page. You should then do Ajax hits to load JSON, and then you should populate the page with node.textContent, document.createTextNode, and element.setAttribute. And then Jeff Williams came at me and smacked me around and said, oh, your DOM-based XSS cheat sheet is all wrong, Jim, and you should just give simple advice like this. And I always love giving Jeff a hard time, and I wrote him back and told him why he was so wrong. And like Jeff, element.setAttribute is basically one of the most dangerous methods in all of JavaScript. The first element can be any JavaScript event handler or URL context, and then you can very easily inject code to pop. So this advice from Barth is decent, his overall architecture is right on, but it's trivial for a programmer to use set element in a way that's incredibly dangerous from a cross-site scripting perspective. So again, the advice that I'm seeing from the world experts out there, myself included at times, is wrong or incomplete, because a lot of the security guys are just that. They're security guys. We're in a new era, folks. To stop applications, to fix these problems of web applications, the security community is not going to do it. I'm sorry. We don't have that ability. It's the developer era right now. So if developers don't engage and understand and apply some of these techniques, all hope is lost, in my opinion. No web application firewall is going to solve the problem. I've never found a web application firewall I couldn't bypass in a couple minutes. So I kind of see that as a mythware kind of industry, I hate to say.
And we were talking about before, the stuff's not going away.
No, it's not.
How many vulnerabilities we see out there that are on the top 10 list, and they've been there? And, if I'm doing pen testing with bad guys for real, if they see that you're running a critical protocol, they see these old things, they're just going to exploit it. So you do a lot of fancy defenses, as you said. The security engine is not going to fix it. It's not going to fix it. We got to fix it from a development aspect.
I concur. I really do. We don't always have that luxury. Like if it's a COTS system, if it's a turnkey system, we have to kind of lean on the vendor and do other things. Maybe use a web application firewall to stop the bleeding, make it harder to attack it. But there are situations where fixing the code is very, very challenging. But when we have that ability, the long-term sustainable way to fix our applications, no question about it, is to fix the code.
And if you're working for vendors who's selling those applications, that's a really point to stop it. We could stop it there. Or if you're putting dead, code, packages, bundle up, make sure that it's good, test this stuff out, and try to correct it in the package.
So here's the problem with today. The problem is that we as a security community are doing a very bad job of telling developers how to fix these problems, but yet the only way to long-term fix these problems is to influence developers to write code differently. So that's why the web is such a radically insecure place today. Really good for us security vendors, really bad for those who care about security though. So DOM-based XSS, we see Adam Barth, one of the world's top guys in this topic, giving sketchy advice. So here's the advice I think is best, and it's unfortunately not simple. This was written by Adam Kong, Gareth Hayes, Stefano DePaula. We had about 10 different people write this guide, and I'm just showing you like a little less than a third of it up on screen here. Untrusted data should only be treated as displayable text. You shouldn't be driving data that I see like PhDs do this a lot. They'll pass a function name as a parameter to dynamically call functions. You got to take those people out back and Jack Bauer them totally. Thank you. I mean, that kind of cleverness almost always leads to insecurity. The best programmers in my mind, the older I get and the more I code, the dumber my code is. Simple, modular, easy to maintain, easy for newbies to look at my code and use it and modify it over time. So I think clever from a development point of view is evil. The best developers I know are ones who write simple, modular, maintainable code. And that's not always as fun to write code that way, but I think it's better from an engineering point of view. Avoid the eval statements, only parse JSON with JSON parse. When URL encoding in the DOM, be aware of character set issues. I'm not going to talk about this in great depth. For those of you who are heavy JavaScript programmers, or if you have heavy JavaScript programmers within your team, point them to this URL, the DOM-based XSS prevention cheat sheet. For a JavaScript programmer, it makes perfect sense. Unless you're deep into that technology, it's not going to make a lot of sense. Sir? Of course. Yeah, this is an open deck. I'll publish this to LastCon for sure. So the other use case today that we're not addressing well is JavaScript sandboxing. So how many of you point to a JavaScript file that's hosted out of your control and execute that within your domain, within your website? I've done that in the past. What's the most popular third-party JavaScript file in the world that most websites render on their homepage in some way? No, hang on. No, jQuery is a different story. jQuery is when you're taking a third-party library and deploying it in your site. I'm talking about when you actually include JavaScript that's hosted on a third party and remotely include it into your site, and you just said it, Google Analytics or AdWords and advertising networks. So let's get this straight what you're doing when you're using Google Analytics. You're putting a remote JavaScript include on your page that makes a hit to Google, grabs their JavaScript file, and brings it into your browser and executes it. Oh, but don't worry, we can trust Google. They're not evil, right? If Google all of a sudden got evil, or if someone hacked Google and was able to modify analytics, I know what you're saying. Oh, no one could ever hack Google, right? Google's already been hit horribly. Did you hear what happened to Google beginning of the year? Google's single sign-on code was stolen by hackers around January, right around Christmas time of last year. So it's not will Google get hacked. Google's already been hacked many times in horribly vicious ways. Their entire single sign-on code repository was already stolen beginning of the year. So if Google got hacked or Google got evil and they swapped out their analytics JavaScript file to be something else, what happens? Do you ever see the movie Aliens 1? What did the guy say when the aliens were charging him from all directions? Game over, man! Yeah, exactly. If analytics gets compromised, it's a mass compromise of the entire web for the most part. That's what we're looking at. To fix that problem, we do sandboxing. My favorite tool for the world of sandboxing. Oh, as we move to ECMAScript 5, we'll have object sealing, which will address some of these issues. But even that's not complete. We really want to do some kind of sandbox. So my favorite one is from Gareth Hayes. Gareth Hayes wrote the JSReg project. It's a very complicated set of regular expressions that will take untrusted HTML and untrusted JavaScript, parse it and using the JavaScript engine itself, and strip out window references, take all global variables and localize them into individual functions, and take the entire JavaScript safe object property list and whitelist the proper use of it. I don't like this architecture. It's all blacklist filtering. But Gareth Hayes is one of the sharpest guys on the planet. A lot of people have tried to attack JSReg and compromise it. That he's fixed a few problems early on, and it's now reached a point where it's very much stabilized. And so I highly recommend you check out this project. It solves a problem that nothing else well addresses. That is the sandboxing of third-party JavaScript that you're remotely including in your sites. So again, hey, just do output encoding and all cross-site scripting goes away, right? No way. The problem is way more complicated than that. So here's my view of how you stop cross-site scripting today. And this is the most important slide in this deck. I want you to grab it, copy it, steal it, claim it for your own, I don't care, and pass it out to everyone. Because this is the reality of how we stop cross-site scripting today. Let me walk through this. This is important enough. So number one, if you have a numeric piece of data, let's say user is sending you an integer, a float, some kind of numeric type, and let's say you have a type-safe language. What do I mean by a type-safe language, developers? PHP, is there such thing as an integer class in PHP? There's really not. When you have a PHP variable, it's always just a string. Now you can do validation to check if it's an integer, that's fine, but a string is a string. So we really don't have numeric types in PHP. In Java, if you have an integer variable, is there a way for us to inject a string into it? It's just not possible. In Java, an integer is an integer. There's no way to embed a cross-site scripting attack in an integer variable. So in Java, if we have a numeric variable, we don't have to worry about this problem. We just render that integer wherever we want, life goes on, and we're done. Now, if we don't have a type-safe language, if we're dealing with just strings, then we need to do a lot of that encoding we talked about and other things. So if we have a string and the destination is the body of an HTML document, we just do HTML entity encoding, and that's the right thing to do. If we have a string and it's going into an HTML attribute, but it's a formal template like velocity or or some kind of formal template language, then we only need to encode the double quote and the single quote because we know that attribute's going to be quoted, and that's enough. Now, if we're in an open template like Java server pages or just some kind of PHP template that's just wide open with no structure, that's forced, we need to account for the possibility that the developer may not quote their attributes. So if you're putting untrusted data in a context without quotes, they can use a space to hop into a new context. So in the case of a quoted HTML attribute, we want to aggressively HTML entity encode. We even HTML entity encode spaces and pretty much everything except for letters and numbers. So we do aggressive HTML attribute encoding. Now let's suppose untrusted data is landing in a get parameter. Like you have a hard-coded URL as an href link, /site/feature $data equals blank, and that blank is coming from a request parameter that populates that URL that's about to be clicked on. Make sense? So that's, in that case, we want URL encode to stop cross-site scripting and still let the feature work properly. The problem is we used to say, if someone sends you a URL, just URL encode it. That sounded really good, but it's security guy thinking, because if you actually tried to do that for 3 minutes, you would see, and I was shocked, like Williams did that. I saw, I like to give him a hard time, but I saw several other people of his caliber saying to do URL encoding of URLs even the last couple of weeks, and it's flat out wrong. Guys, try it. Well, they're just security guys. You know how they are. So it's a joke, an attempt at humor. I'm sorry. So if you take a URL and you URL encode it and put it in an href tag, click a lot, nothing's going to happen. It just breaks the URL. So if we have an untrusted URL that's coming from a third party, here's how I do it. Number one, on input, I do URL validation. If that URL is not properly structured, I reject the input and have them try again. So now we know that the URL is a good URL. We then check to make sure it's not a JavaScript URL. Pop a browser. Let me see if I can do this quickly. I can just pop a browser here. Oh, I think the latest version of, oh, please, I'm probably going to get bit here. I think Firefox just stopped doing this, which they did. Let me try one more. Nah, a lot of browsers are no longer supporting this. Alert 1 more try. Nope, they're shutting it down. What other browser can I, Safari? Do I have Safari on here? I probably do. If I want to find insecurity, just pop. If I want to find insecurity, just pop an Apple product. Sorry for you fanboys. Give me I need a 5. Yeah! I love, Apple. All right, so yeah. Oh, who gives it? Apple fanboys, raise your hand. Yeah. That was classic. That's one of my greatest moments as a presenter, by the way, ever. Apple. All right, so as we can see, a JavaScript colon is a real type of URL. Every browser popped it about a year ago. They're starting to lock this down. But so when I'm validating a URL, if I see JavaScript, if it starts with the word JavaScript in any way after I decode it, bang, I'm going to reject that as well. And now we're taking this URL and we're going to put it in an href tag to be clicked on. You do attribute encoding because the source tag of a link is just an attribute. It's a quoted piece of data in a tag. So we just do attribute encoding, and that URL will be safe from cross-site scripting because you can have a URL with the cross-site scripting attack payload in it, and it's still a legal URL. So we have to both validate the URL and do the proper output encoding. If we take that URL and we're just displaying it in the body of an HTML document, we'll do HTML attribute encoding. But if we take that URL and put it in an actual tag to be clicked on, we do attribute encoding. If we take that URL and we put it in a JavaScript variable assignment, we'll do JavaScript hex encoding. So you encode the URL based on where it lands. It usually lands in a link, though. So if we take If we take untrusted data and put it in a cascading style sheet value, encoding's not going to help the cause. We want to do contextual output encoding. I'm sorry, let me rewind. When you have cascading style sheet data and you're putting it in a cascading style sheet value, encoding's not going to help you here. You need to do strict validation. Whitelist validation is not enough. You need to do structural whitelist validation. Whitelist validation tells you you can or cannot use these characters for the most part. Structural validation says your data needs to be in this specific format. So if you're driving color, if the user gets to type in a color, your code needs to say, unless that text is exactly white, blue, green, blah, 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 then otherwise reject it. Or if it's exactly in the format pound and 6 digits, the hex color format, otherwise reject it. And now you know you can safely put that data in a cascading style sheet context. Your output encoding doesn't help you here. So suppose you have data that's HTML, you can't encode it. You need to do proper HTML validation. In Java, it's the JSoup library. There's the Anti-SAMI project. It's real complex configuration. There's also the HTML sanitizer project. If you need high-speed HTML validation, Michael Samuel from Google was kind enough to donate Google's HTML sanitization code to OWASP. So this is, I can barely even understand his code. He's a very smart guy. He wrote his own parser from scratch using no third-party libraries. This thing is fast and furious. And we just put out a site called CanYouXSSThis.com to give people a chance to break Google's HTML validator. And we had a few people crack through it already. We're fixing it. That's why we're calling it beta, because we are in beta. We'll get there someday. If you're now within the DOM, if you're in the context of moving data from one widget to another within JavaScript, you want to do sandboxing using the JSReg tool or something similar. And if you're parsing JSON on the client, it's a very common use case for modern applications. You're making an AJAX request, you're getting back JSON data, and if it's a modern browser, you need to use JSON.parse. If it's an older browser, you want to use the JSON2 library, which has parsing. The JSON website itself, the JSON authors and standards holders, they say just parse JSON using the eval statement. That'll work. It's really fast. But if any JavaScript sneaks into your JSON object, it executes at parse time. So even the advice from the people who maintain the JSON standards body themselves, they're giving really bad advice in terms of how to parse JSON. I'm not trying to attack anyone. I'm just trying to bring everyone back into the circle to give good advice to developers, because when it comes to security, I don't care about security people anymore. I care about developers, because that's who's going to change the world today. And I think that developers tend to be a lot more, they tend to have a lot more knowledge about this specific technology than security people do. The kind of problems that developers are solving day in and day out are so complex already. I don't think this stuff is that much more complex than what you're trying to pull off already. So I think it's accessible knowledge if you're given the right information. And I dare say, hopefully in a non-arrogant way, that this is the right information today to stop cross-site scripting. I'm out of time. I'm going to talk about the future real quick. And my hope is that when we look at cross-site scripting 5 or 6 years from now, all of this goes away. We still need to parse JavaScript correctly, but my hope is between sandboxing, Firefox's content security policy, and contextual aware auto-escaping template technology, 5 years out, we're going to have frameworks and code and infrastructure available to developers where if they just code to this specific technology, cross-site scripting goes away. So I really invite you to research content security policy. It's probably the most important of all these technologies. And you know what? That's it. I'm from Hawaii, so we say shaka bra and sista. Thank you so much for taking time. Any questions before we finish up? Or? Yes, sir.
After JavaScript, a lot of this kind of things be like, oh, hey, we got JavaScript, what more we can do with it? And it was never really meant to go into such flexible things.
Well, if you're not doing JavaScript, you're not building websites today. Dart. I'm a bit of a Google fanboy. The Dart programming language is Google's evolution after JavaScript. And I believe that it's a radically safe language compared to what we have today. My hope is that something like Dart gets pickup, or ECMAScript 6 reduces the language heavily. I think mostly we're just screwed. We're stuck with JavaScript for a very long time. It's not going away anywhere. Was this helpful? Was this good? Right on. Thank you.